Okay, good day, everyone. So we'll get started in terms of reviewing for the test number 3. We call that final exam, but it's not cumulative as you notice. So before we get started, do you have any question? Right. So one more time, you go to the Blackboard, and then under the review for the exams, right? You should be able to find a review sheet. And definitely, if you go over beforehand, it will be really helpful. It's a couple of questions interesting. We haven't mentioned in the lecture time, a lecture section. So if you try on your own, it will be interesting experience. Okay, but yeah. So now let's look at the review sheet. Okay, so first one is about dice. Okay, so you probably barely see this dice with anything other than 6 faces, right? But there's some options out there. I see 8 faces dice, 16 faces, and 24 faces. That's also available. So it depends on how they manufacture the dice. It's doable. Okay. All right, so now look at the first question. Actually, it's similar to the question you have in the home session from your home assignment. Okay. All right. So so part A, a 24 show up, right? So it basically is a single number, and we know 24 faces. That with 24 faces, there are 24 numbers available. So for part A, it's just going to be 1 over 24. Okay. And for part B, a number greater than 8 come up. Okay, greater than 8 meaning from 9 to 24. And the total amount of number there, it should be 24 minus 9, adding 1. You need to make sure you add 1, meaning you're including the first number. So here is 15, adding 1, which is 16. Meaning there are 16 numbers satisfying this condition. So here we should have 16 out of total 24. If you simplify, reduce by 8, dividing 8 on both top and bottom, you get 2 over 3, 2/3. The chances are 2/3. And part C is no less than 7 come up. No less than 7 meaning 7 and above, right? 7 to 24. But again, a total amount of number here, total numbers here should be 24 minus 7, adding 1. And that's 17 adding 1, which is 18. Okay. So here the probability no less than 7 will be 18 over 24. Okay. And reduce both top and bottom by 6, you get 3/4. And typically, in terms of final, the test number 3 and final exam, you want to keep it, let's say if this exact fraction, you want to keep as this. So you don't have to run it to a decimal number here, right? Because you're going to get 0.66666, right? And exact answer is better. So I do prefer exact answer, right? So when you submit your solution for the final, make sure, if it is exact fraction or exact decimal, leave it as this. Okay, and exact answer.
Professor, I have a question.
Sure thing.
So if we're solving all of these in Excel, won't it give us like the decimal answer? So would we just convert that into the fraction then?
You could do that, but if the worst scenario you can't convert it, take the decimal answer. Just make sure you run it properly.
Okay. Thank you.
Okay, no problem. Okay, but in the real life or in your workplace, you want to keep the probability as accurate as possible. So that's why the exact answer are preferred answers. Okay, and D is an even number comes up. So we know that 24 faces, there are 12 even numbers. We know it's 2, 4, 6, all the way to 24, right? 12 even numbers, and then 12 odd numbers. So basically that's breakdowns. So the probability of even number will be 12 over 24. So it's half. In the case it's a well-rounded fraction, like half, right? You can turn it into 0.5, no problem, or 50% if you prefer. So either answer will be good, right? Either one of these answers will be good. If it is, they are equivalent, and then they are exact answers. Here is 0.75, and then 75%, right? They're all equivalent, perfect solution. Okay. And that's part E. Part E, we get an even number, a number between 9 and 20, including 9, including 20. All right, so here we need to figure out how many numbers between 9 and 20, 9 to 20, right? Again, that 12 numbers, you're using 20 minus 9, adding 1. So 11 plus 1 is 12. That's 12 numbers there. So probability of number between 9 to 20 will be 12 over 24. Again, it's half. Right? Okay, so 0.5 if you prefer, or 50%. All right, so this is question number 1. Any concern or anything you want me to clarify? All right, so this is question 1, and let's take a look at question number 2. Okay, so a coin was flipped 4 times. Okay, so this is a coin and binary event, right? So anytime you have 2 outcomes, it's called binary. Like the computer system, like newborn babies, they're all binary, right? So basically, a lot of real life applications come from this, the model of the probabilities. So that's so they are very useful. Okay, now let's look at this question. So one way to do this is you can come up with all the possible outcomes, just like what I show you in the class. We can create a tree diagram. Right, just create that, and let's list all the outcomes. Then the rest of the question becomes straightforward, right? You just gotta go in there, look at all the outcomes, satisfy each condition, and find out the corresponding probability. So maybe let's do that, right? So coin flip 4 times. First one, let's use the multiplication rule to get a total probability. Total possible outcomes here. So first trial, second trial, third trial, and then 4th trial. Each trial, we have 2 outcomes. So it's 2 to the 4th, meaning we expect to have 16 outcomes, right? All right, that's what we expect. And this is useful. I'll show you why, because when you flip coin 4 times, it becomes slightly more complicated. So we want to make sure, we did not miss out any outcomes here. So we start here. And this is the first trial, right? First time you flip it. Now you get 2 outcomes, either head or tail. Okay, that's first flip. And the second flip, second time you flip it. Again, we have 2 outcomes. Okay, and then we're gonna flip it 3rd time, right? And you will notice that when we flip it 4 times, then it becomes slightly more complicated. And make sure you have all these branches laid out properly. So this is the 4th time, right? And once you have this, then you actually ready to list all the possible outcomes and make sure you have all these listed. So more space actually is slightly better. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You want to make sure on the 4th one, you're going to have 16 possible outcomes there. So now in that case, you guarantee to have all 16 outcomes listed properly. So the first outcome will be all heads, right? Head, 4 heads. Second outcome is head, tail. 3 heads in a row and 1 tail. Third outcome, hat, hat, tail, hat. Hat, hat, tail, hat. Okay. Fourth outcome is hat, hat, tail, tail. So this is quarter of them, right? We've complete quarter of them. Now the second quarter, hat, tail, hat, hat. Okay. And then the next one will be hat, tail, hat, tail. Hat, tail, hat, tail. Next one is a hat, tail, tail, hat. And a hat, tail, tail, tail. Notice that we completed half of it, right? So first 8 being listed. Now move on to the second half of the branch. The tree was cut off here. Okay. Now we start with the tail. So tail, hat, hat, hat. And then tail, hat, hat, tail. Tail, hat, hat, tail. Now tail, hat, tail, hat. And tail, hat, tail, tail. Now move on to the, so this is another 4, right? It's the last quarter of it, last 4. Tail, tail, hat, hat. And tail, 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 hat, tail. And second to the last is tail, 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 hat. The last one is another extreme case, which is 4 tails, tail, 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 tail. And I should double check, make sure it's 16, right? So 2, 4, 6, 8, 10, 12, 14, 16. So that means you have the right result. Now you look at all these outcomes and counting what is probability that 3 hats comes out, right? So you're going to counting which one has 3 hats. This one has 3 hats. Right? This one has 3 hats. And this one has 3 hats. One more, right here. This one has 3 hats. So its probability of 3 hats will be 4/16. So it's a quarter chance. Or you can write 0.25 or 25%. Yeah, either one is good. Okay, that's part A. And part B is what is probably none of them are hats, meaning has to be all tails, right? So it got to be this one. None of them are hats. So another way of saying that is 4 tails. So we only have one outcome satisfy that, so 1/60. Then part C, you're going to counting exactly 2 hats. Okay, I'm going to use different I'm going to use triangle to measure those exact 2 hats, right? So this is one of them. Maybe use different color, so that'll help you distinguish them. Let me just use different color. Okay, so this one. Okay, maybe I'll also circle that. Yes. And then also 2 hats. This one has 2 hats. Okay, another one. 2 hats right underneath it. It's another 2 hats. Okay. And 2 hats right here. And 2 hats. Another 2 hats. Right now you count how many? 1, 2, 3, 4, 5, 6. So that means we get a 6 out of 16. So 6/16 and 3/8. Again, this exact fraction, and it's well-running fraction, so you can turn into 0.375 or 37.5%. Either one you prefer, right? They're all good. And the last one, probably was probably no more than 2 hats. We have 2 events embedded under no more than 2 hats, right? Either 0 hat or 1 hat, right? No more than 2 hats. Okay. So there are 3 events here, and we actually can do this. We can go the other way, right? We're using complement. You can go straight. Find out what is 0 hat. We know all tails, we have that. We have 2 hats available, and just find out 1 hat, right? So that's no more than 2. You can also solve it using complement events. No more than 2 hats. So it's basically probability of 0 hats. We already calculate that, right? All 4 tails is 0 hats. 0 hat plus probability of 1 hat plus probability of 2 hats. Some of them we already did a calculation. So 0 hat is 4 tails, 1/16. We know that. And we also know 2 hats because we just calculate that, right? So it's 3/8 or 6/16. It's slightly easier. And we just have to find out how 1 hat. Okay. So go back here and then let's check how many of them has 1 hat. I'm gonna use a different color. This is one. Okay. This color. Okay. So now check 1 hats, right? So this one has 1 hat. This one has 1 hat. And what else? 1 hat right here. And then what else? Okay, this is 1 hat, right? So we have 4 of them satisfied. This one, and the one underneath it. So it's 4/16. 4/16. Now we just combine them. So 1 + 4 + 6 is 11/16. And this one you probably want to leave as this. So let me see if it is exact answer. So 11/16 definitely works. Oh yeah, we can turn into exact answer. It's 0.6875. We can write it as, so this one's good, this one's good, 68.75% to be exact. So that's how you solve this. Any questions on this? Okay, very good. And now let's look at question 3. Let's say in a statistics quiz, you need to answer 5 questions. And we're assuming we're just randomly guessing this, right? Again, we're assuming we're not starting and just randomly guessing these answers. We're going to find out what is will be the probability of getting all answers correctly. So probability of all questions correctly. Meaning with 5 questions, all of them has to be correct. So remember the first 2 questions, true and false questions. So you have a half a chance to get it right, right? And then by the time you move on to the last 3 questions, multiple choice with 5 answer choices, that means for each question you have a 1/5 chance to get it right, 1/5. You can also look at it this way, right? I'm going to show you another way right now. This is one way to look at it. So this is first question, second question, third question, fourth question, fifth question. So first question, 2 answer choices. Second question, 2 answer choices. Third one, 5 answer choices. Fourth one, 5 answer choices. And fifth one, 5 answer choices. Multiply across using multiplication rule. We know that it's 125 times 4, that's 500. Meaning you have 500 different choices. However, only one of them is correct, right? So the probability of only one combination is correct combination. So probability of all questions answers all questions correctly will be 1/500. Okay. That's how you look at it. Another way is using, just look at each individual question, find out the probability of getting correct answer. Multiply across, you also get 1/500. Again, this is exact fraction, and you can turn into a exact decimal. and this turned out to be 0.002. Also, you can look at it as 0.2%. Okay, so either one of these answers will be perfect. Okay. Let me know, right, if you have any question on this. Okay, before we move on to question 4. Question 4 is about with or without replacement. So let's look at this. So basically, this is a very famous ERM question, and this type of question are very famous in the probability field. So in ERM, we have 20 green balls, 18 red balls. If 2 balls are randomly selected without replacement, so this is a key thing, right? No replacement, meaning you pick a ball and that ball is gone. You do not put it back. You examine the color and put it away. That's exactly what it's trying to tell us. So we know that there are total 38 balls, right? 38 balls. And out of 38 balls, 20 green and 18 red. Okay, that's a breakdown. Now you want to find out first one is green ball. And second one, second red. So, and these 2 events are independent events, right? So these 2 events independent because getting a green ball does not guarantee you're gonna get a red ball on the second try. Similarly, getting the first green does not guarantee you're gonna get second green, right? That's why they are independent. So the probability of getting the first green ball has no impact on probability of getting the second red. So basically, we just look at it as multiplication rule. First green times probability of second red. The only thing we have to account is the without replacement. Meaning you pick a green ball for the first trial. And we know we have 20 green balls out of a total 38 balls, right? That's probability of getting a green ball. However, once you pick a green ball, now we only have 37 balls left. Right? For the second, we need a red ball. So we still have 18 red balls remains. So that's how you get this result. And if you want to simplify, and this one, you know, we can keep it as exact fraction, but you just have to simplify that. So you get 360 on top. On the bottom, let's see, 38 times 37. And that's going to be 1406. Now you're going to reduce it, right? So it becomes 180. Reduce both top and bottom by 2. 180 over 703. And I don't think we can reduce any further, so we leave as is. 180 over 703. So if you do have to put into a decimal answer, let's say if the Excel give you decimal answers, then you're going to get 0.256 approximately, right? So this is approximate answer, approximately 25.6%. So the key concept here we apply is without replacement. Okay. And that's question 4. And let's look at the question number 5. So in the company, there are 15 members on the board, right? 4 members, 15 of them. And you do intend to elect for the first part A. It's very similar to the one we talked about during the class last time. About when we talk about permutation versus combination. So now the main difference is permutation order matters. Meaning we do rearrange those board members we picked, right? We assign each one of them a title, and that becomes different subject. And then for combination order does not matter. So that's a major difference between these two probability calculation. So for pi, we intend to elect chairperson, vice chair, and then secretary. How many different slots? Different slots meaning how many choices are there, right? So again, we're picking 3 board members out of 15, and order matters because each one will have a different title. So this is definitely a permutation. Okay, so part A is permutation. Satisfy the description of the permutation. So we do permutation is NCR, right? So N here is 15, no, P. Write it one day. Okay. NPR. Okay. So N here is 15 and R is 3. So we do have 15 P3. Okay. So if you, let's say you want to do it by hand, that's doable for this type of question. So I'm going to do it by hand. So this is basically n factorial over, so this is n factorial over n minus r factorial. So here will be 15 factorial over 15 minus 3 factorial. So you get a 15 factorial, that's 15 times 14 times 13, multiplied by 12, 11, and all the way to 1. You can put a couple more numbers there if you want to. Or you can list the entire sequence of numbers. On bottom is a 12 factorial, so start with the 12 times 11 all the way to 1. As I mentioned last time, for factorials, you can cancel the same number after 12. It's all gone, right? So all you have to do is multiply 15 by 14 by 13. Okay, now we get 2,730. Okay. I'm gonna show you how to do in Excel really quickly in a bit. And here the order matters for permutation. For Part B, if they intend to elect ethics subcommittee with 5 members, and here and everybody has same title, committee member. So that means order does not matter. We do not rearrange those 5 members. I have to pick from the 15 total members. So here definitely is a combination. So we get NCR. And N here is 15, R is 5. We're picking 5 members out of 15 members. So it's 15 C5. So we get a n factorial over n minus r factorial times r factorial. So it's going to be 15 factorial by n minus r, that's 10 factorial. 15 minus 5 is 10 times 5 factorial. And one more time, we can do it by hand, right? No problem. It's not too bad. 15 times 14 times 13. This time I'm going to list all the numbers. Okay. 14 times 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And let's list the 10 factorial first. So it's going to be from 10 all the way to 1. And the 5 factorial will be 5 times 4 times 3 times 2 times 1. Everything after 10 is canceled. Okay. And here we can simplify, right? 3 times 5, 15. So that cancels 15. And then 4 going to 12, that's 3 times. 2 going to 14, 7 times. So eventually we end up with 7 times 13 times 3 times 11. Okay. Let's see what that is. So 7 times 13 times that. So 3003, right? Different choices. Okay. And now I'm going to quickly check it with Excel. And in Excel, you just have to write and put in the right formula. I should be able to get a result right away. Okay, in Excel. Yeah. Any question? Okay. Okay, so computation first. So we do 15P3, right? First. So it's a permutation. So you put equal sign here and put PRMUT. And total amount of number 15, we're picking 3 numbers out of 15 and get 2,730, right? That's it. And then we also have a 15C5. So combination. So COM, BIN, parentheses, we have 15 numbers, picking 5. And one more time, you enter 3003, right? So either way, if you prefer to use Excel, no problem, go ahead. Use Excel. It's so much quicker. So this is question 5. Question 6 is about conditional probability. And let's look at it. And try to understand the essence of the conditional probability and try to see. So this one is a 2x3 contingency table. You have 2 rows and 3 columns, 2x3 contingency table. Basically, we have 2 genders, male, female, and we have 3 different age groups. First age group is 16 to 19. So you probably want to calculate the total for each group. For age 16 to 19, when you sum up those, it's 101. And the second age group, 20 to 29, if you add up those, it's 116. And the third age group, 30 to 39, 47 adding 21, that's 68. And we can also sum up the total on the row right? First row, males, we're adding all the males. So 55 adding 62, also adding 47. And this turned out to be 164. Meaning out of this, in this particular survey, we have 164 male members, and then let's see, female members should be 46 adding 54, that's 100 adding 21. So it's 121. And you want to know the total amount of the, so here, right, this is total amount. So sum up 164 adding 121, you get 285. Meaning we have 285 people being surveyed in this particular study. And now they want you to find out the conditional probability of having accident in New York City. So for pi, so for male driver, given that the age group, so probability of male driver, given condition that is between 16 to 19. So that means you're going to look into the total amount of people falling in the age group 16 to 19. And here we do notice that there are a total of 101 people in that particular group. And for that particular group, total amount of people 101, 55 of them are male. So we do 55 over 101. Okay. So that's exactly what they try to ask you, right? So they want you to find a percentage of male drivers in this particular survey under the age group between 16 to 19. And this is that answer. Actually, I prefer that. So if you can leave it as is. Part B, age group between 30 to 39, given that it's a male driver. So the given condition is a male driver. So you're going to look into all the male drivers, 164. Out of 164 male drivers, 47 then fall in the age group 30 to 39. So you do 47 out of 164. And that's how you get the probability for the second one. Okay. So try to understand it in the detail fashion, and definitely you'll be able to get it very quickly. If you want to run it as a decimal answer, first one should be 51 by 101. It should be 0.545. Make sure the rounding is proper. So this is approximately 54.5%. Okay. And for PABI 47 by 164, and this turned out to be 0.287. So approximately 28.7%. So, all right. So this is question 6. And then let's move on to question 7 about expected value. And this has to do with one of the game in the casino. And that basically gives us an idea, how your odds in terms of playing any of one of the casino games. So when you give Venetian Casino in Las Vegas, you bet $10 on number 8 in roulette, right? And we know that there are 38 numbers in the roulette game. So if you're betting on just single number, you have 1/38 probability of winning $150. And you want to look at your expected return. Okay. So you look at this outcomes, only 2 outcomes. Either you win the game or you lose the game, right? Only 2 outcomes. And now in terms of monetary reward, if you win a game and your monetary reward, okay, so X, right? That's what we call monetary reward. Remember, you bet $10 and you're winning $150. So your net gain, in this case, net gain will be 150 minus 10. So you get $140 net pay, right? And if you lose, you can only lose $10. So minus $10. And now you look at the probability associated with each one of these outcomes. For winning case, you have 1/38, 1 out of 38 chance of winning this game. So 1/38. And only one winning number out of total 38 numbers. For losing, there are 37 losing numbers, right? So it should be 37/38. Okay. And according to expected value formula, so average outcome, right? You expected value equal to summation of X times P of X. We need to create a product of X times P of X. 140, so maybe let's just keep it as a fraction for now. 140 times 1/38 is 140/38. Okay. And the other one is negative 370/38. And if you combine them, so negative 370/38 plus 140/38. This turned out to be negative 230/38. Now we divide into that 230 by 38. That's $6 and then negative $6.05, right? Again, this is rounding. Since we're talking about a dollar amount, so always run it to 2 decimal place. So what this telling us is every time you play this roulette game, every time you play the roulette game, you expect to lose $6.05. Roulette on $10 bet, you expect to lose $6.05. Okay, that's what the interpretation of this expected value is. And creating a table definitely will help you organize all the informations presented from the question. Also, some analysis. You still got to do some analysis before you can get to the final solution. Okay. And then for any gambling activity or investment activity, you only have two outcomes. You either win or lose, right? And there's no other options available. So actually that will make it slightly simpler. So you just have to, and they are complement of each other, winning or losing. Okay, and this is question 7. Question 8. All right, so about car games, right? We didn't talk about too much on the car games during the class. So now I'm gonna give you some background information on this. So in the standard deck of car, so you have the standard deck of car, right? We know that there's 13 clubs. Okay, so let me list all 4 suits. In the French word, it's called suits. So we have 13 clubs, 13 diamonds. Okay, and 13 spades. And also 13 club, diamond, spades. And there's one more suit. Let me think, what is that? It's also hearts, right? I forget hearts. Okay, so we know that the total will be total 52 cards with the 4 suits. Yeah. And for each suit, we have a 4 ace, right? 4 king, 4 queen, 4 jack, 4 3, right? All the way to 4 of 10, right? So basically that's a breakdown of the standard deck of the cards. Now this is important information here, so try to make sense of this. And then what's probably the first card is a king of the diamond. The first is a king of diamond. How many king of diamond are there? There are 4 kings, right? But a king of diamond is only 1. So these 2 events, first of all, they are independent. Because when the dealer dealt the card, it's random selection. You randomly pick the card. So that gives us idea that they are independent. So you look at getting the first king of diamond. Second is a heart. And those 2 events, they are mutually exclusive, meaning they do not have intercept. So first king of diamond, we only have 1 king of diamond, so it's 1/52. And then heart, since it's king of diamond, so it has nothing to do with all those 13 hearts. That's why we call they are called mutually exclusive, right? They do not have any intercept. That means that, so we still have 13 hearts. However, we only have 51 cards left. Okay, and that's basically how you multiply these 2, and you can simplify this. 13 to 52 is 4 times, so this basically becomes 1/4 times 51. It's 1/204. So this is exact fraction. But if you want a decimal answers, it's fairly small decimal answers. So this is approximately 0.0049. that means you got a approximately 0.49% of chance of having this sequence of cards, right? First king of diamond, second heart. Okay. Any questions on this? Okay, so that's card games. So anytime, next time you go to casino, play card games, if you remember, you learn something in the class, and you can apply this a little bit. Okay, so question 9. So we have this, Esther is a basketball player who makes 80% of the 3-point shots, right, which is pretty decent rate. So assume that the results of each shot are independent. If Esther attempts 5 3-point shots, find the probability that she misses at least 1 3-point shots. Misses 1, right? What is the complement of complement event misses at least 1? So at least 1 here will be 1, 2, 3, 4, 5, right? That's too many events. So it's easier to handle this problem using a complement. Complement event of misses at least 1 shot is misses 0 shot. Okay. Now, another way of saying this is makes all shots, makes all 5 shots. So this is very crucial, right? You come up with the proper complement event. So probability of at least 1 misses at least 1. It's equal to 1 minus probability of misses 0 shot. Another way of saying that is make all shots. So it's 1 minus probability of makes all 5 shots. We know she had 80% accuracy rates, right, to make each shot. So if you look at each, we have 5 different shots. First one, second one, third one, fourth one, fifth one. Each one has 80% of chance being made. So 80%, 80%, times 80%, times 80%. Okay. So you just multiply all of those, and it's 0.8 to the fifth power. So this is 1 minus 0.8 to the 5th power. And again, you need to put into the calculator or Excel to get a result. 0.8 to the 5th. And this turned out to be 0.67 232. And typically, we do not keep more than 4 decimal place for probability, but since this is the exact answer, I guess I'll keep it as this. But if you want to run into 4 decimal, that's fine. So 0.6723, meaning 67.23% of the chance to make at least 1 3-point shots. Okay. Any question on this? All right, so question 10 is about New Jersey Pick 5 lottery game. New York City also have their own game, right? So every state basically have a game. It's pretty interesting. Let's look at it. Okay, so New Jersey Pick 5 lottery game, winning the jackpot requires you select 5 different numbers from 1 to 56. So between 1 to 56, there are a total of 56 numbers, right? So this is how you do the calculation, 56 minus 1, adding 1. So 56 total numbers. This is very important, right? If you get the total numbers wrong, then your outcome will be off. So now you want to find out probability of winning. Remember, only one group of winning numbers. How many group of numbers available? Then here we use NCR because the order does not matter. As long as you pick those 5 winning numbers, you win a game. So the order of those winning numbers does not matter. So here will be 56 C5. Okay, and that should be 1 over. And let's use Excel to get a result. Since this is fairly large numbers, the calculation will be a little bit messy. So 56 C5. Okay, so we do combination. Total amount number 56. We're picking 5 winning numbers out of 56 numbers. And you get this. Right? So this turned out to be 3,819,860. 3,819,816. 813, I believe. Okay. Let me quickly double check the number. 816. That's right. 819, 816. Okay. All right, so we got it, right? So it will be this, and then if you, this is the exact answer, you can leave it as this, but if you wanted that decimal answer, that will be a very small number. So it's approximately 0.000000 with 6 zeros and 262. Okay. So if you want to turn into decimal answers, then you want to keep this amount of decimal, right? At least maybe up to 26, right? If you want to skip one decimal, that's fine. But this kind of accuracy is required in order to, explain this probability to somebody who have no idea what probability is, right? The chances winning, it actually is kind of low. Okay. And that's question 10. Question 11, which is the last question. In the factory, machine X produces 40% of daily outputs, machine Y produces 60%. And it's very similar to the one we did during the class. We call this Bayes theorem, right? It's a Bayes theorem. And Bayes theorem is an application of the conditional probability. It's a special type of conditional probability. And then we typically use a tree diagram to look at it. And it's very useful in terms of understanding the relationship and also the breakdown of each outcomes. So now we have 2 machines, right? Machine X. Think about it. If let's say we have multiple machines, X, Y, Z, right? Many machines, you can still use a tree diagram to understand the structure, also the relationship among those different machines. And we know that machine X produces 40% of the outputs, machine Y produces 60%. And out of all those outputs, some of them are good ones, some of them are defective ones. Good, defective. Right? And sometimes it's important for manager to understand which machine works better, works more efficiently. So you can look into the detailed breakdown using Bayes theorem and come up with your proper conclusion about it. Now, defective rate for machine X is 3%. So this is 3% basically, defective rate, meaning 97% of output are good. Okay, so if you want to put it here, that's fine. 97% or 3%. Same thing for machine Y, right? Similar layout, 2%, no, 98% good ones, 2% defective ones. 98% good outputs and 2% defective rates. Okay. And one day an item was inspected at random and found to be defective. And we know that defective come from this source, could be machine X, could be machine Y. Okay. And we want to see like what's the chance that you will be, what's the probability that you will be produced by machine X? So the way how we write this will be probability of X, given that we find this to be defective, right? This is prior information. And then now we're going to get to the posterior information, which is after this information was revealed, what's the chance we can trace back to machine X? So here, so you look at machine X 40% times 3%. Okay, that's a chance for machine X to have a defective items. And then combine machine X and machine Y. So 60% times 2%. On top, we get 1.2%. You multiply that, or you continue decimal numbers if that's easier. It's going to be, yeah, so it's going to be 0.4 times 0.03 on top. On the bottom is 0.4 times 0.03, adding 0.6 times 0.02. And this actually turned out to be 0.12 by 0.24. No, 0.012, is it? Yeah, 0.012 by 0.024. And this is exactly half, meaning you have 50% chance this defective item come from machine X, 50% of chance it come from the machine Y. Okay, so that means both machine sort of like work equally efficiently, right? In this notion, using a conditional probability. So, and then that's how you will handle this type of problem. So I will draw the tree diagram, understanding what you try to solve. Here we try to find out the percentage of the defective item coming from the machine X, right? And two machines both produce defective items. So you want to find out percentage of defective items produced by just machine X. And that's how we handle this. Any question on this last review question? We have no other questions. We still have some more time. So if you have any question on the Excel project number 6, I can talk to you on an individual basis. So I'm going to put all of you guys in the breakout room. Talk to me if you have any issue with the Excel project number 6, which is last one. And it's due, let me double check. I think it's due today, is it? Let me look at it. Should be Excel project submission. Yeah, it's due. It is due today. So yeah, definitely get it done by the end of today. And it's basically the difficult one is the bump price. And we actually, you did that in the test number 2. In terms of finding the bump price, you need to discount the face value using the compound interest formula. Also use annuity, present value of annuity formula to discount all the dividends, right? Remember, you receive a dividend on an annual basis. You also need to discount that. So that's actually what you have to do on question 4 and 5. Some of you have issues with that. So let me just, if you still have issue, I can help you, guide you through when I put you in the breakout room. Okay. And then again, one more time, next Wednesday will be the last day of the semester. You are required to take the test number 3, and we count it as a final exam on Wednesday. And then I have to submit a grade shortly. So so there will be no makeup for the final for test number 3. Okay. All right. So now let me put you in a breakout room. Talk to me if you have any question. Hey, Alexandra,
Hi, Professor. How are you?
how are you doing?
So I'm still having trouble
Mhm.
with question 4 and 5 from project number 6.
No problem.
So if you could help me, I can either share my screen or you can, I don't know, guide me
Yeah,
through
share your
it.
screen, please. Yes, let me take a look at your progress.
Sure,
Be helpful.
sure.
Okay.
Um, how can I do that?
You can just, you see on the main interface, do you see share screen?
Um,
Um,
no,
no?
I just see like participants. Oh yeah, share screen.
Yeah.
Yeah.
Try that.
Okay, desktop 1, share.
Very good. I can see that now.
So here it is. So usually I don't know, I would use like this formula to sum
Yeah.
up with the compound interest.
Mhm.
But then you said the annuity formula, which is this one. So I don't know, I'm confused.
Yeah, so for the face value, right? Face value is it $10,000? Let me look at the question.
Yes, it is.
$10,000. So we need to discount, meaning we need to discount the $10,000 back to the present time. So we're using compound interest formula to do that.
Yeah, which is this one, right?
Yeah, exactly. But for
Okay.
dividend, yeah, right. So you get that one right, perfect. And then
Okay.
for the dividend, you see, the dividend is paid out on a yearly basis.
Yes,
Coupon rate, what is the coupon rate? It's 5%, right? So 5%
correct.
of $10,000 will be $500. That means you are getting the $500 from for the first case, 5 years will be getting $500 for 5 years in a row. So
Uh-huh.
you need to find out the present value of all those annuities.
Okay, so I should use like this formula.
Exactly,
This one.
annuity formula. That's right.
Okay, so I guess I did that here. I don't know if my numbers are correct or not, but
It looks good. Yes. And then after that, I gotta sum up those two sources, right?
okay, so I sum up this one with this one and this one with this one, and then
Exactly. Right.
okay.
Yeah.
Okay.
Sum up
Okay,
those sources.
and the same for the question number 5. So I didn't get this one
Yeah,
right.
exactly. Very similar, right?
Mm,
The only thing is that the condition changes slightly in terms of
okay.
year, also the
Okay, so here I use the wrong formula, right?
yeah, you gotta use the
Okay.
well, actually it's the right formula, isn't it? This is the right formula.
This is the one.
This is the present value of the annuity. That's what we talk about in the class. The only thing is I is equal to R over N. That's why the two formulas look different, but they are the same. Same thing. I is annual interest rate over number of compounding period.
I see.
I is
I
interest
see.
rate per compounding period. Yeah.
Okay, so I guess this one, so I guess number 5 is correct. I just have to maybe adjust the question number 4, right?
Yeah. And then it's payable yearly, meaning the compounding period is once per year.
Okay.
N equal to 1. So I is the same thing as R, right? So
okay. Yeah. Correct. Okay. Thank you, Professor. I think I get it. Thank you.
Don't worry. Hey, Kevin.
Hey, I was just wanted to ask you a question about Excel project number 6.
Definitely. Do you have a specific question from your progress? You can share the screen with me, so I can look at your work.
Okay. Yeah, I'll try to share my Excel.
Okay,
It's number 4 that I'm having problems with.
definitely. Um, okay, very good. I can see your screen right now. Perfect.
Yeah.
Um,
So I don't really know how to set up the Excel chart, like the table.
This is fine. The way how you set it up is fine. But just remember that this bond price come from two sources, right?
Yes.
You just have different interest rate and different amount of time. That's all. And yeah, so this is a good setup. Just make sure you put into the table form. That should be good. And
Okay.
the important thing is calculate each one of the bond price. So for first one, for example, it's 3% interest rate, and then the time is 5 years. So
Mhm.
here there are two things to be discounted. First one is the face value, meaning in 5 years you're getting $10,000, and how much are you willing to pay for that $10,000 now? So we're going to use a compound interest formula to calculate the present value of the face value. So you're going to discount the face value to the present time using a compound interest formula.
Okay.
Yeah.
Compound.
Does that make sense?
Yes.
Okay, very good.
Do I have to combine that formula with the other?
Yeah, you got to combine it with the other one, right? The other one is discounting on the dividend income. Dividend income is like interest income you receive from the company. So it's 5%, and then the face value $10,000. That means you're getting $500 every year, right? And you also want to discount that cash flows. Like in this case, for 5 years, every year you receive $500, and you want to make sure how much is that 5 payments of $500 is worth right now. So we're going to use annuity formula, present value of the annuity formula, to calculate that, to find that present value of all those dividend income.
Okay.
Yep. And you know which formula to use, right? In terms of the annuity.
Would that be the coupon one? The
present value of the annuity formula.
I
think you have it right here. I think it's good. B56. You should let it vary, right? It shouldn't be an absolute value of B56. It's NT. So should let it vary. So here on the formula, leave out the dollar sign in front of B, in front of 56.
Okay.
So when you calculate the other ones, so what is B56 first of all? Let me ask you, what is
B56 would be the time.
the time? Yeah, the time changes, right? For every single calculation, the time changes.
Yeah.
It could be for the first group, right? From 1 to, oh yeah, I guess you can use that, since for the B column, you can use the times all 5. For the second one is all 10. So you're good. So basically this is, but it looks slightly off. I see. For the 56, 1 plus 857, why the number is off slightly for some reason? That means the formula is off. So it's 1 minus 1 plus our n, which is 857. That's good. Raise to this, close parenthesis, close that. So this is good, over 857. So this is the bond price. But the price looks off a little bit. Okay.
Oh, okay.
Or maybe, for the other one, for the compound interest, it's no negative sign in front of the B56.
Oh, okay.
Just 1 plus R to the to the NT. And then N is 1, T is 5. So it's just going to be positive 5. So 10,000 divided by. So get rid of the negative sign in front of the B56 in terms of calculating that discounted face value.
Okay. Is that formula fine though? Like the structure of it? 'Cause I know you said to remove
Yes.
the negative.
First part of it is it's correct. The second part, when you divide 10,000 by 1 plus R raised to NT, there's no negative sign in front of the NT.
Okay.
Only for the annuity formula, there's negative, right? Present value by
Okay.
annuity is negative power, but here it's not negative power, it's positive power. So get rid of that negative sign in front of the $B. Let's do it.
Okay.
Yeah.
All right. Thank you.
Yep. So modify that. I think that everything else should be right. You have the right formula. The calculation is good. Yeah.
All right. Thanks for your help.
No problem. Yep.